Okay, so you might be asking yourself at this point, when I start coming across questions like find the x-intercepts of the graph y equals x squared minus 2x minus 3, is it all the same fun and games of completing the square in order to solve for the vertex and all that other stuff? Well, no. If we're asked to find the x-intercepts, remember that the instructions actually meant that we find an x-intercept at any location where the y-coordinate is 0. So we set y equal to 0 and solve the equation. And in this case, if there's no need to find the vertex, we can simply set to 0 and find out what's going to happen. So let's do that. If I had 0 is equal to x squared minus 2x minus 3, what should I do? Well, in fact, we have any number of methods to do this one with. I'm going to go ahead and complete the square in order to find it. If I complete the square, x squared minus 2x will equal 3 if I add 3 to both sides. And then I complete the square by adding 1/2 of x's coefficient squared to both sides. So 1/2, so x squared minus 2x plus 1 will equal 3 plus 1. And this is going to give me x minus 1 squared is equal to 4. And so when I isolate x, I take the square root of both sides to get positive or negative 2. And so x will equal either negative 1 minus 2, or x will equal negative 1 plus 2. So my x and y coordinates are at the point x equals negative 3, or x equals positive 1. That places us at negative 3, 0, right? Remember, we initially set y equal to 0, or 1, 0. Now, if you're interested to see how this all operates in terms of the graph, let me show you something. I think this is really cool. Here's our x-coordinates. Negative 3, 0, 1, 0, right? Let's take this graph. Let's sketch it out here. Come on now. Doesn't want to cooperate with me. Come on now. There we go. Okay, here we go. Ready? Uh-oh. Did I do a sign error? I did a sign error, didn't I? What did I do? Added 3 to both sides. 4 plus or minus 2. Oh, yes I did. Hey, look at that. See? I missed because, hey, I do this all the time too, right? This is why you got to watch us. And no, come on now. Stop doing that. Stop doing that graph here. Hold on 1 second, everybody. Okay, so this should have been plus 1 here. This should have been plus 1. So that gives me positive 3 and gives me negative 1 right here. So let's try that again here. Our x-intercepts are at positive 1 and positive 3. Sorry, negative 1 and positive 3. So negative 1, 0 and positive 3, 0, the location of my x and y intercepts here. So taking care of the little errors right here. Negative 1, 0, 3, 0. Yes, okay. What did I want to point out? Well, take a look at what goes along the center of this graph. If I were to graph it out, you would see the line x equals 1. And notice that x equals 1 is exactly at the midway point between 3, 0 and negative 1, 0. 2 to the left and 2 to the right. So if you wanted to work your way backwards, you actually could and find out that our vertex must occur at a point where x is equal to 1, and you would find that y is equal to negative 4. And without even having to go through and solve for your vertex, if you happen to know your x-intercepts, if you happen to know what's right in the middle of those, guess what? You're set. Okay, here, let me try this. Let's find the zeros of f of x equals 2x squared minus 3x minus 2. And let's see if we can guess where that vertex is. All right, so in this case, here's what I'm going to do. I'm going to take my graph right here. Let's work this out. If we set this equal to 0 and solve for x squared, or solve for x, let's see, 2x squared minus 3x minus 2. You know, this doesn't look like it's going to be the easiest thing in the world to factor. So what we could do is we could use our quadratic formula. Why not, right? So x is equal to the negative of b, so negative 3, plus or minus the square root of b squared. So we're going to take negative 3 and we're going to square that, minus 4 times a, which is 2, times c, which is negative 2, divided by 2 times a. So that's 2 times 2. All right, what does that work out to be? Well, x will be equal to positive 3 this time, plus or minus the square root. Let's put in our numbers for our square root here of 9 plus 16 divided by 4, which is to say x is equal to 3 plus or minus the square root of 25 over 4, which we normally call 5, right? Plus or minus 5 divided by 4. So what does that mean to us? Well, we're going to get x equals 3 plus 5 over 4. So that's 8 over 4, or 2. And we'll find that x is equal to 3 minus 5 over 4. So that's negative 2 over 4. And that's going to be negative 1/2. Well, that means our x coordinate will be at negative 1/2, 0 as one point, and at 2, 0 at the other. Now I know this is actually factorable, and I probably could have figured this out. But if we're interested in finding the location of our vertex, let me point something out here. This is the reason why this formula is really, really useful. What is the midpoint between negative 1/2 and positive 2? Answer, negative 1/2 plus 2 divided by 2 to find our midpoint is the same thing as negative 1/2 plus 4/2 divided by 2 over 1, which is to say 3/2 times 1/2, or 3/4. And look at our parabola right here. Look at what we just did right here. We took x was equal to 3/4 plus or minus the square root of 25 over 4 in our formula. That is the location of the vertex. Pretty cool, right? That is a great way of finding a vertex, is by using your formula, right? That's negative b over 2a right there. And not only that, our axis of symmetry is that line, x equals negative 3, x equals 3/4. All right, so the x, our coordinates right here, our quadratic formula is good for more than just solving equations set equal to 0. All right, more in the next video.